Question 1, lesson 6, page 48. A cannon, this is part 2 of using quadratics here. A cannon 10 feet off the ground launches a cannonball straight up with a velocity of 406 feet per second. Imagine there's no gravity and the cannonball continues to travel upward with the same velocity. Complete the table with the height. All right, so it's starting 10 feet off the ground. So that's the only difference here. We're starting 10 feet off the ground. How far will it go in a second?
416. Well, 406, but plus 10.
It's traveling 406 feet per second. So 406, plus 10. Another second, it's going to go another 406 feet. So 406 plus this. 822. 406 plus this. 1228. 1228 plus 406. 12 plus 4 is 16. 28 plus 6 is 34. 16 plus 4 is 20. 34 plus 6, 40. What is my equation? How am I getting those answers? Well, you're starting at 10, and you're taking 406 times however long it's in the air. Write the equation. Well, you already have it. You already have it written right here. It's D equals 10 plus 406t. Okay, linear. Right, going on forever. No gravity there. Question number 2. Says we just figured out one with no gravity. It's going to go on forever. Table shows actual heights of the ball at different times. So this is what actually happens. Compare the two values. Make at least 2 observations. So 2 observations of this data compared to the last one.
Second one is less.
Heights are less. What else?
It's not linear.
Not linear. Hopefully you can see they start at the same height. Start at 10, both of them. Now, why is that? It's also not adding the same amount each time. Why? Gravity. That ball is slowing down, not getting as high. So we're going to graph those. Next page, we're going to do the first one. At 0, it's at 10. 1 is at 416. 2 is at 822. 3 is at 1228. 4 is at 1634. 5 is at 2040. And that is ignoring gravity. The other one, starting at the same spot, it's 400, 758, 1084, 1378, and 1640. Could say that's the actual height, or including gravity. So what would you expect the blue one? Well, that's just answer B, I guess. That's answer B. How are the two graphs alike? Same starting point. Both are discrete graphs, dots, right? Just have dots. Caring about every second, right? I'm looking at the same time. How are they different? Well, the blue one's going to continue on forever, linear. What's going to eventually happen to the black one? Yeah, eventually that's going to come back down. Shoot a cannonball, anything in the air, it's not going to go on forever. So can we come up with an equation to get the actual distance? Well, it's still distance equals. I'm still starting at 10. And it is still fired at a velocity of 406 feet per second. Now there's one thing that I have to keep in mind. One thing my equation's missing. You mentioned it, what was the equation for that? Talked about it yesterday. We have an equation that has gravity built into it. What is it? So that's the part that's missing. This is what's going to make the ball come back down.
So that's how second one.
Yes. All right, so question 3. What do the terms 50, 312, and negative 16 tell us? All right, so it gives us a new equation there. What's the 50 tell you? Yeah, in regards to this problem, a little more specific. Yeah, the height of the cannon. At the beginning, initially. And that's in feet. What's the 312 tell you?
How much for the height?
In regards to the cannon.
How many, the height and.
Velocity. It's going up that much feet per second. 312. Last one I think was, I don't remember, 406. Okay, negative 16. T squared. Well, that is the gravity pulling it back down to our location. Okay, go ahead and plug that equation into Desmos that it gives you. And then we will discuss it.
Oh, why is there two bars? Oh, I
What?
said instead of T, put an X.
I put X. I don't know if it'll like T or not.
That's kind of cool.
Go ahead and adjust your window. Book recommends X being from 0 to 25. So that's your
Right.
X-axis left and right. And it wants your height to be up to 2,000, 0 to 2,000.
Whoa.
Okay. 0 to 25 is what it recommends going this way.
I don't even know where that leaf pipe was.
What? All right, so again, this is what you should have. You adjust the X this way. It recommended 0 to 25. and up to about 2,000, and that you adjust this way. So there is the height of the cannonball. And obviously it does come back down. Now from this, I could tell you when it hits the ground, highest point, starting point, all of that. So number 3 says, observe the graph and describe the shape of the graph. Okay, describe the shape of the graph. Parabola. Upside down U. Okay, the ball goes up and comes back down. What's it tell us about the movement? Well, we just described that. Cannonball gets shot up, comes back down. Estimate the max height. Well, we can get pretty close just by estimating. Looks like we're going by hundreds, just shy of 1,600. We should be able to almost click on that. A dot should pop up and we can get the actual height. I can see 9.75 seconds into this, it gets a height of 1,571. So we're going to give an exact 1,571 feet. And that point, guys, is called the vertex. The vertex. Okay, when does the ball hit the ground? That is called a 0. It's going to have a height of 0. 19 seconds. 19.659 seconds. What domain is appropriate? Remember, domain is X values. I obviously don't care about negative time, so my domain would be from 0 to probably 20 would be a good spot to show that. So from 0 to 20. Time has to be positive. And it's already at the ground at 19, so I don't need to go past 20. I suppose you could figure out how far into the ground it goes, or if you shot it into a canyon or something, it could continue on. Last one we're going to look at is that are you ready? It says if the cannonball were fired at 800 feet per second, would it reach a mile in height? Okay, well, our height is still 50. We're going to shoot it at 800 feet per second. Still going to have gravity to deal with, so we're going to just type that into our equation again. I guess you would have to know how many feet are in a mile.
How much? More than 5,000, right? Yeah, it reaches about
5,280 feet in a mile.
This reaches 10,000.
Yeah, this one's over 10,000. So almost 2 miles in the air. So 5,280 feet in a mile. Thank you. Oh, I was going to show everybody your piecewise function.
Yeah, I'm so glad you brought that up, actually.
Okay, your homework then.
I made my whole yeah, so did I.
2 terms. Want to make sure you know. If it asks you for vertex, guys, that's the top or bottom of the parabola. Okay. That's called the vertex. 0 is pretty self-explanatory. That is when the y is 0. So this one right here on the previous page would have a 0 right here.
Wait, so the vertex.
This one would have a 0 over here, but we would not be worrying about negative time. So it's when it crosses the x-axis is a 0. Yes?
The
Correct. It's where the parabola starts, no matter the direction it goes. Okay, took a look at your homework then, starting on page 53. Does go to 56. Question number 3, you're just going to plug both of those into Desmos. Just screenshot that and answer the question. Put them both on one graph. It says which one hits the ground first. That should be pretty obvious when you graph them. Four is also from this section. 5, 6, and 7 are from this unit. So is 8. So 9 is the only one that's from last unit. So 8 out of the 9 should tell you if you know what you're doing here. Thus far, 6 lessons into this unit. So go ahead and work on those. Watch for the word explain and let me know if you have any questions.